Welcome, welcome to Correct Science. Today, we are going to explore an amazing concept in physics, motion of connected bodies. We'll just be considering one part of this. Let's not waste much time. So here we have two bodies, M1 and M2, and a force F is acting on M2 to the right. Now we are to find the acceleration and the tension in the string. So they are connected by a small string here. I don't know if you can see this string. Very small. And there's a tension in the string. Okay. How do we do it? So the force is acting on the two masses, M1 and M2. So the total mass is given by the sum of the masses as M1 plus M2. So if we consider the two masses as one body with a certain mass M, and it's acted on by a certain force F, then the acceleration, we know that from second law, Newton's second law, will be the product of the mass and the acceleration is given the force. So you just get F over M to be the acceleration. But in this case, M is equal to the sum of the two masses. So if we do that, then what we are going to get is A is equal to F over M1 plus M2. This is the acceleration. But now, how do we get the tension? So we are considering one string, and usually in physics, when we consider a string, we have some conditions. So it's an inextensible string that it cannot be stretched, and also we consider it to be massless. So the force acting on the string is not able to cause any acceleration of the string at all. So in this condition, then the string will have the same tension across it. So the entire string will have the same tension. So why are we saying this? Let's say we consider the tension to T1 and T2 based on the two masses. So the T1 is the tension in the string as a result that is pushing or pulling M1 forward. And T2 is the tension in the string that is tending to pull back the M2. So for M2, both forces F and T2 act on it, and for M1, only T1 acts on it. But we are saying that T1 is equal to T2, given a tension of T, because the string has the same tension across it. As explained earlier, it is massless. So the total acceleration is zero, the total mass is zero. So the total force in the string will be zero. So T1 minus T2 will be zero, meaning T1 equals T2. So based on that, we are saying that the tension is T. Now, from there, how do we get the tension T? Okay, so let's consider a system where, let's say, we only had M1. Now, the tension T1 tends to pull, rather, the mass M1 forward. So it pushes it with the same acceleration as the whole system. So from this, we can see that T, which is the force on M1, is equal to M1 times A, which we've already found. So based on that, we get T is equal to M1A, which is M1F over M1 plus M2. Now, what if we consider M2? So for M2, there are two forces acting on it, looking at this diagram. So for M2, the the tension tends to pull it away, and there's this force. So the acceleration of the M2 object, which is the acceleration of the system, times the mass of M2 will be the net force acting on it. But since it accelerates in this direction, it means the force wins. So F minus T will be equal to M2A. This is the net force. So to get a tension using the mass M2, it will be F minus M2A when we make it the subject. But already know that F is equal to M1 plus M2 all multiplying A. So M1A plus M2A, then minus M2A. So you still get M1A. So that's one simple way of getting the tension. So based on this, we can always find the tension in the string and the acceleration in this case. So where the force is attached is our M2, right? And the other side is the M1. So always the tension can be given by the other mass where the force is not applied times the acceleration. Or if you want to use the mass to where the force is applied, then it will be the force that is applied minus M2A. Thank you for watching. But I don't want to leave you empty-handed. There's a nice question here I would like you to try. So here we have a 2 kilogram object and a 4 kilogram object tied to each other with a string. We are to find the acceleration of the system and tension in the connecting cord if a 12 Newton force is applied on the 4 kilogram object such that the system moves with a certain acceleration. Give your answers in the comment field. This is correct science.